It's always great to have a big engine on a bike, but there are also some problems with it. First of which is you don't want to drive it slow, and the roads and turns or other circumstances doesn't allow you to do so. While riding in high speed, if you face a scenario like these, you are compelled to make multiple downshifts or decelerate the engine suddenly. This may cause engine over-revving, which is not good for engine, or it leads to rear wheel chatter, wheel hop, traction loss due to sudden engine braking, which is not good for you as it may cause serious accidents. To avoid such situations, sports bikes and modern cruisers have slipper clutch. And there is one more modification of this slipper clutch which is called slip and grip clutch or assist clutch, which lightens the effort required to declutch. So let's untangle how both of them work. First, let's understand the system condition. Let's consider the engine is running at 2000 rpm. The gearbox is converting it to 1000 rpm with a reduction ratio of 2:1. And let's consider the gearbox is transmitting that motion to the wheel via a chain at ratio of 1. Hence, the wheel is also revolving at 1000 rpm. Now, due to any situation, if you downshift 2 or 3 gears directly, then when the clutch is engaged, with the engine running at same speed, this will happen. Consider the gearbox ratio due to downshift is now 4:1. Now the 2000 rpm running engine wants the wheel to suddenly change its revolving speed to 500 rpm due to the ratio of gearbox. But the wheel, due to momentum, is running at 1000 rpm. Now either the engine will suddenly change the speed of the wheel, which will suddenly decrease the speed of the bike, creating slippage and loss of traction, which would be dangerous. Or 1000 rpm running wheel with its momentum will try to transmit back power to the engine, and due to which it will try to rotate the engine crank at 4000 rpm due to the gearbox ratio again, which will try to overrev the engine. Either of these things are not desired. To solve this problem comes the role of slipper clutch. The function of slipper clutch is to allow slippage, means light disengagement of clutch when the wheel is providing back torque. So when the wheel tries to run the clutch output shaft faster than the engine is trying to run it, the clutch should allow some slippage to help match the speed more gradually, rather than suddenly compelling them to match speed. This is ideal for engine life as well as traction of the bike, reducing the risk of an accident. Here's how the mechanism of slipper clutch works. This is the engine side and this is gearbox and wheel side. When engine is transmitting power to clutch, it runs at higher speed than the driven shaft, which connects the input of the gearbox. As the driven end is facing resistance to motion due to load, it tends to run slightly slower than the engine speed. So this is running faster and this is running slower. So these sections come in contact and both of them rotate together. The springs are putting the pressure on the drum, which forces the clutch packs together, transmitting the motion to the gearbox from the engine. Now in case when engine speed is reduced drastically or multiple downshifts are done, then this side becomes relatively slower and the momentum of the wheel wants to drive this shaft at higher speed. In such case, these ramps come in contact with each other from this side, and due to the angle and higher speed of this side, the drum slides backwards. This results in increasing the gap here. So now the clutch plates get more space and now they cannot be pressed together with that sufficient pressure. Hence, some slippage occurs. This slippage allows the engine and the wheel to match speed gradually as required. Now let's see the slip and grip modification of this slipper clutch. This is how the modern slip and grip clutch looks like. This clutch has ramps on either side. So when the engine accelerates, the driving side spins faster. This forces these ramps to slide on each other, decreasing the distance between them. So when the engine accelerates, the driving side spins faster. This forces these ramps on this side to slide on each other. Hence, the space here decreases. This puts pressure on the clutch plates. This increased pressure holds the plates tighter, hence increasing the friction, As this mechanism does the work of pressurizing the plates together, lighter springs or less number of springs are required here to pressurize these clutch plates, as now both of them share the work. As lighter or less number of springs are used here, it is now more easier and lighter to operate the clutch. That's how the assist function or slip and grip function of a modern slipper clutch work. Thank you for watching. If you learned something new, go check out other videos on our channel and subscribe for the new ones. If having any question or comments, feel free to mention them down in the comment section below. As of for now, I'm signing off and see you guys in the next week.